Hello everybody, this is going to be our first video on actually developing the DQN agent in our game. So hopefully you guys have everything set up, the neural network library, the game, the playing game, and it runs well. So test out by running, test out playing the human player just to see if it moves. So if we got that all situated, to start with, we have this player factory that is going to instantiate and create a DQN agent into the level. So go to level. Here's our level, and basically when we start the game, we're trying to load in the player. As you can see, when we're in, go to the level object, the level.tscn. Double click it. It should open this, and then go to player factory and see how human player. We have a scene that it's going to load up. So we basically need to find human player and basically just duplicate this and call it the DQN agent or DQN player. And here we have it, and this is basically going to be where our code for the player lives. So once we have duplicated this, just switch over to 2D and you should see now the DQN player. So this is the player that we're going to be adding raycasts on, because for the agent, remember in the DQN we need to give it data on the environment it's in. So we actually need to add a raycast to this player. So the way to do this is on the player. This is the player object. We're going to go and add a child node and search raycast 2D and create it and kind of like just line it up, just kind of like that. Maybe make the length 100 just to give it a wider view range. And we're going to basically wrap this agent or this player in all raycasts around it. So I'm going to do that right now, and we want to follow the naming convention of this. So here I am creating these. Actually, let's change these to 150. Keep these at 150 just to give it a wider range. And the naming convention should be something like this. So raycast up. And this needs to be named exactly like this. If it's named differently, it can cause some problems. And also just a note, you can open transform to rotate a raycast. You can just type in values like this and then just move it on the agent. So here we go, add child node. Make sure you're always adding it to the player. Now for diagonals, we're going to need to actually basically do 150, 150. Doesn't need to be perfect, but it's better to have it line up good. Now for the diagonals, make sure the naming is exactly like this. So the up or down is associated at the first, and then the direction or side is the second. So down right, down left, up left. And a quick way to do this is you guys can just right click, duplicate. So up right, and we could just reflect this along the y-axis, or along the x-axis. We can just turn it to 131 and then it flips over there. So here we finished, and this is all the namings that it should be. So make sure it's exactly like this, and they're associated with the right orientation. And So now that we have all of the raycast set up, we want to go back to that level.tscn, and here the DQN agent scene, we want to load that DQN player TSCN right there. So now when we load in, it should have that agent right there. Now you should see that when you play the train your agent, but in the human player still can play train your agent, still plays because we still have the code, but we'll change this soon. So now that we have this level and DQN player set up, let's create a script that the DQN agent's going to run on. So go to the res, create new folder, and let's call it DQN agent. In the folder, create a new script called DQN underscore agent, and open up this script, and it's going to be empty, but we're going to build off the current human player. So open human player file, and for now let's just copy over everything into this new DQN agent, just so we can have it set up and running on a new file. So to link this to the new player, let's go to the DQN player scene, and as you can see, we have the scene with the raycast. Go to the player and click it and scroll down to script on its inspector. Scroll down to script. So scroll down to script. Load a new script. DQN agent GD, and there. So now there's a new script. Save it with Control S, or just save, and click play. Train your agent, and it should still play normal, but now it's a new script that we can make changes on. So if we go into the script now and change something like DQN agent initialized, and we play the game now, you'll see it outputs this. So we're in this script now. We can make changes to this and add our agent to this. So let's go to the DQN player TS scene, and we see the raycast. Oh, this is misspelled. We need to make sure everything is spelled right. Make sure everything looks like this. And let's go into the script now. So let's open the script right here. And let's get the vision going. So let's try to get the vision set up. So we're going to need an object to save all the vision data. And we're going to need a function to actually update the vision and grab the collision points. So update vision. Since all the raycasts were children of the player object, we're gonna get the children of the current object, and if the child is a raycast 2D, we're just gonna get the collision data. So if the child is colliding with like an obstacle, then we're gonna get the collision point for collision distance, and this will be the distance from the center of the character to the actual wall. So how long and where is that colliding? So we can do that with child dot get collision point to get the collision point of the raycast. Then we could just get the current position of the agent and get the length of that. And to save this to the vision object, we just get the child.name. So this is going to be raycast down is going to equal the collision point, so or collision distance. So something like that. And then if it's not colliding, if the raycast is not colliding, we'll just set the we'll just set the raycast data to like something high. So like the agent knows there's nothing it's colliding with, or there's no obstacle for a long time. So now that we have that, we can basically just call this. We can test it real quick. So we can print vision after each time after calling update vision, and we should get vision data now. So see, like right here. So it is outputting the raycast data. So now I guess we can't really see, but if you check, like maybe raycast right as we move changes. Anyways, raycast data is going to change while the agent moves around. Now we just need to implement the actual movements to make this agent take actions by itself without like user input. Because right now, we're moving by ourselves. We need to make sure it can move just without any user input. So when we think about it, what actions are possible for this agent? So we know it can move right, left, and it can jump. So it can do a combination of 3 moves. So let's try to implement this with code. So things like handle jump, handle movement, we actually don't need these anymore. We can delete those. We do need gravity to be applied each time. Okay, so we can make the movement. So let's just create a function called execute action. And this will take an action, and then maybe the delta. We might need the delta just to handle the frame rate. This is just a variable we always need. And in this, we're going to basically have, so an action can be either 0, 1, or 2. And let's say 0 is move right, 1 is move left, and 2 is jump. So with this, we can make a match action. And so if it's 0, we want to basically take the velocity dot x, and we want to make it equal speed. And then we want 1 to be velocity dot x equals negative speed to make it move left. And for 2, we want basically probably just a function like jump if possible, which we'll implement, because remember, we can double jump. So if the agent is like on the floor, then they can double jump, or if they haven't used up all their jumps, then they can double jump. So jump if possible. So let's say if the current underscore jumps, because we have this already as a variable, current jumps, this will keep track every time they jump, it's going to add. So if the current jump is less than jump count, we're going to add to the velocity equal to jump velocity, which is already predefined for the agent. We can't really change that, or else we'd kind of be cheating the game. So we're going to add to the current jumps, and the time since add to the current jump. And yeah, so this should now jump if possible. We also want a way to, we want to reset. So like if we need to check each time if it's on floor, then just reset current jumps to 0 because they hit the ground. And then we could just call move and slide, which is a function just to get the agent to move. We also need this. Whoops, move toward velocity dot x speed times delta, just to make it smooth. And there we go. So now this should work. So like let's say let's just make it move right. So like, let's just repeatedly call execute action 0, and delta will be just delta. And then let's just run this and see it moves right. So it's working. It's executing actions for the agent. So overall, I think that will wrap up our video on just setting up the agent, setting up the environment, adding it to the level, and everything's working, and we should see how that works. So next video, we're going to get into actually developing the neural networks, setting up neural networks, the hyperparameters, all that stuff to actually make the agent start deciding on actions. So thank you for watching, and hope you enjoyed.